we have one final simplify the expression or the complex fraction, and this one says 4 divided by 3y minus 5 divided by 3x, all divided by 16x squared minus 25y squared, all over xy. So I have a tendency to write down whatever the problem is a second time, and you may have noticed this already or maybe not, but let me explain why I take my time to rewrite the problem even though it's like literally right there. I do that because it gives me time to kind of analyze what I'm writing. It helps me read it out loud so that I can see what I'm dealing with, and so I can prepare mentally for the next few steps. So in this case, when I was reading it, I noticed that there's a 3y, a 3x, and then xy in the denominators. So if I want to find the LCD, I must focus on those three things. And technically the LCD would be 3, x, and y, because 3 is a multiple of 3 and 3. X and y are both in there, so that would be the LCD. So that's the reason why I spend my time writing the expression down. And now what I want to do is the same thing that we did previously. I'm going to give each one of those fractions an extra factor, this new LCD that I discovered or that I decided. So in this case, the 16, the negative 25y squared, all together in one fraction over the xy. I'm going to surround them with parentheses just because. And I'm going to give each one of these fractions a 3xy and then a 1. So 3xy over 1, and similarly 3xy divided by 1. So at this point, let's see. If I multiply and divide all the fractions, what will I end up with? So the very first fraction, it has a 3y on the numerator that can be divided with a 3y on the denominator. So when I divide them out, I'm going to be left with 4 times 3 times x times y divided by 3y times 1 is going to be at the end just 4x. With the second fraction, I do something similar. So 5 times 3xy divided by 3x times 1 will be at the end just simply 5 and y. And earlier there was a minus in the middle, so I'm just going to keep writing it down. Now for the denominator, I already have the 16x squared minus 25y squared, and it's going to get multiplied with 3xy and then divided by xy. So the xy's are going to go away. I'm going to be left with the 3 at the end. Now keep in mind that 16x squared and 25y squared is actually a special pattern. The 16x squared minus 25y squared can be written down as 4x all to the power of 2 minus 5y all to the power of 2 as well. So this is again an example of a difference of squares. So here we go. Let's factor the denominator out. So we already have 4x minus 5y on the numerator. I have the 3, which I'm going to throw first, and then the old parentheses that was there will switch over, and it will become 4x 5y with a minus one time and a plus on the other one. And again, notice how I'm seeing now a repeating factor, 4x minus 5y in the numerator and again in the denominator. So if I wrote that without putting anything else, I may be tempted to write down on my final answer 3 and then 4x plus 5y just like this, which is actually an incorrect solution. This is not the correct answer. That's because technically when you divide things, they become 1. They don't just go invisible. They become into a 1. So this is technically 1 over 3 times 4x plus 5y. So it's the reciprocal of what I thought it would be. So that's important. That's the reason why we want to write down all those ones. And if you're wondering whether you should multiply the 3 with the 4, the 3 with the 5, so some of you will do that. We'll write down 12x and then 15y. Either way, it's fine. But just as a rule of thumb, we don't like foiling denominators. We don't like distributing denominators. So if it's already nicely factored like it was on the first answer, just leave it like that and it's perfectly fine.